behalf of Namita Gokhale and William Dalrymple and all my colleagues at Teamwork Arts, welcome back to JLF's Brave New World. Those of you who missed our earlier sessions with Piku Iyer, Peter Carey, Chitra Banerjee Devakurni, Yotam Ottolenghi, and so many others, you can catch them on our Facebook page, JLF Litfest, and on our YouTube channel, Jaipur Litfest JLF. To tell you more about the wonderful list of writers we've got lined up for you, please welcome festival directors Namita Gokhale and William Dalrymple.
We are all of us so absolutely delighted by the enthusiastic response from around the world to our stellar new series, JLF, Brave New World. We look at the new life that all of us have to begin, the journey ahead, the learnings, the unlearnings through these sessions on books, on ideas, on mechanisms to cope with and to understand how things are turning around after the pandemic. I urge all of you to listen in to us, to engage with us, to send your suggestions, and to join the Brave New World.
Hi there, we've put together an incredible literary festival for you online, JLF, Brave New World. All the writers we love most at Jaipur, Peter Frankopan, Jhumpa Lahiri, Margaret Atwood, have been joined by a whole galaxy of stars we've never dreamt of actually getting to the festival. People like Peter Carey, Evan Duval, Alain de Botton. It's an incredible lineup. Orhan Pamuk, Neil Gaiman, I mean really, it just goes on and on and on. Come and join us, Brave New World, every Wednesday, Saturday and Sunday evening on a phone or laptop near you.
Thank you, Namita. Thank you, William. Our official radio partners is Red FM, Bajate Raho. Our session today on JLF's Brave New World is Jim Al-Khalili, How Indian Mathematics Transformed the World, in conversation with William Dalrymple. Ancient Indian mathematics and astronomy was well ahead of its time as Aryabhatta and Brahmagupta pioneered the decimal and numeric system we use today. A theoretical physicist, author, and broadcaster, Jim Al-Khalili talks to William Dalrymple about these discoveries and how it reached the rest of the world. Jim Al-Khalili, OBE-FRS, is a theoretical physicist at the University of Surrey, where he holds a distinguished chair in physics as well as a university chair in the public engagement in science. A prominent author and broadcaster, he's written 14 books, translated into over 26 languages, including Pathfinders, The Golden Age of Arabic Science, and his latest work, The World According to Physics. He is a regular presenter of TV science documentaries, such as the BBC's Science and Islam in 2008. For the past 9 years, he's been hosting the award-winning weekly BBC Radio 4 program, The Life Scientific. He's a recipient of the Royal Society Michael Faraday Medal, the Institute of Physics Kelvin Medal, and the Stephen Hawking Medal for Science Communication. He received an OBE in 2007 for services to science. William Dalrymple is the best-selling author of In Xanadu, City of Jinns, From the Holy Mountain, Age of Kali, White Mughals, The Last Mughal, 9 Lives, Return of a King, and Kohinoor. His latest best-selling book is The Anarchy, The Relentless Rise of the East India Company, and Forgotten Masters, Indian Painting for the East India Company. William Dalrymple is one of the founders and co-directors of the Jaipur Literature Festival. Please do remember to comment and ask questions by typing it in the comment section. Do also follow our handles, JLF Litfest, on Facebook, Twitter, and Instagram to get notified on the upcoming sessions. In case any of you drop off due to bandwidth issues, or in case we drop off, which we're likely to, you can find us on our YouTube channel, Jaipur Litfest JLF, or just hang in there and we'll be back on Facebook. Ladies and gentlemen, How Indian Mathematics Transformed the World. Jim Al-Khalili in conversation with William Dalrymple.
Welcome, Jim. Very good to have you back. Your session at Jaipur a few years ago was one of our most popular ever. It's
Oh,
very
thank
good
you.
to have
Yes, it's been 5 or 6 years now, I think, since I was over. Time flies.
I'm sorry that it's under these circumstances that we meet again, but hopefully we can get you back in the flesh before too long.
I do hope so. I do hope so.
Well, over the next 45 minutes, what I hope to do is to, in a sense, weave a middle path between the fact and fiction, the whole, and the great walls of ignorance that surround this fascinating topic. I think in the West, there's almost complete ignorance about India's extraordinary contribution both to mathematics and to astronomy. While in India, in a sense, there's the opposite problem, that people here think that all astronomy came from India, and there is certainly judging by the internet, there's a fair proportion of the country that believes that during the Mahabharata, internet was working, nuclear weapons were being fired from Arjun's flying chariots, and so on. But anyone that reads the chronicles of Indian mathematics, you soon realize, there's no need for any mythologizing because the story is so extraordinary. And the influence of Indian science so great that the truth is every bit as strange, I think, as any fiction. So,
Yeah,
sorry,
no, carry on.
So, to start at the beginning, way back at the time of Ashoka, 250 BC, we get the first versions of the numerals that are used universally now around the world. Maybe we should start there.
Yes, I came to this subject because of my interest in the science of the medieval period in the Islamic Empire, where, of course, that was a place where a lot of these different cultures and texts were being gathered from different parts of the world. So, of course, many came from Greece, from Persia, but, of course, of relevance here from India. And I was aware that what we use today, the numbering system, the decimal system we use today, many people in the West still call it Arabic numerals, but of course we now know correctly is Hindi or Indian numerals or Indian Arabic numerals. I was aware they'd originated from India, but I hadn't really dug into the story of just how far back they go. Because of course they weren't really adopted in the Western world, in Europe, until relatively recently, the last few hundred years. And so that's surprising, because actually the decimal system is brilliant. It's so convenient. Compare it with, I don't know, Roman numerals. Try and do long division using Roman numerals. It's all
B111, 1x, 1x. Yeah.
Exactly. Whereas the decimal system is just so convenient. And I was astonished to see how far back it goes. So we're talking, over 2,000 years ago. So it is quite incredible that the idea of counting numbers in decimals up to tens and 20s and 30s rather than some other base system is absolutely ancient.
So in a sense, there are two different things which we're talking about here. One is actually the shapes of the numerals, the 1, 2, 3 figures that we have on our keypads in front of us at the moment, anyone that's looking at a computer. And the other thing is this idea of place value. One column for units, then tens, then hundreds. And both of those are Indian innovations.
I think certainly we'll probably talk about things like place value and the role of zero and maybe even negative numbers. But yes, the shape of the symbols used for the numbers we are familiar with today certainly go back 2 or more millennia. In terms of the sort of placeholder, the idea that without a placeholder, how would we define, say, the year 2020? You'd say it's 1,000 times 2 plus 100 times 0 plus 10 times 2, which is a very long-winded way of saying it. But placeholders divide up, as you say, the units from the tens, from the hundreds, from the thousands. That probably, I may be wrong, but I think it goes back to the great Indian mathematician Aryabhata.
Tell me about Aryabhata. He's what 499 is the date usually given to him for when he writes his tracts.
Yes.
So roughly, what's happening in the West at that time? Rome has fallen.
The Islamic world hasn't been born yet. So it's really the beginning of the Dark Ages in Europe.
But in India, we have the beginning of the Gupta period.
Absolutely. So, Aryabhata, wonderful mathematician. I guess certainly from the West's point of view, the greatest influence did come from Brahmagupta, because it was his text that was translated into Persian and into Arabic and then into Latin. And that's, it was, so for me studying the Islamic world, it's interesting to see what are the books that they regarded as the must have. These are the books we have to understand. Of course, you had the work of the Greeks, Galen, book on medicine, you had Aristotle, you had Euclid's book on geometry, and of course you also have Brahmagupta's Siddhanta, which in Arabic is called the Sindh-Hind. It arrived, so Brahmagupta is 7th century AD, or the Common Era.
And we should mention that Brahmagupta comes from Rajasthan. There's a good Rajasthani festival. He's
right.
near Mount Abu.
I don't know how well known he is in the rest of the world, but I think if I were to draw up a league table of the greatest ever thinkers in history, I would put Brahmagupta up there in the top 10, top 20 in the world in history. He was so influential. What's interesting is that when his work was translated into Arabic, it was extremely obscure. Now, my understanding is that the Siddhanta, which in Sanskrit I think means the doctrine or the tradition, was written entirely in verse. That was the tradition then. You'd write this whole thing in verse.
Memorization, I believe.
That's right. That's
right. Way that you could teach mathematics with these.
Yeah, exactly. Ropes to help with rote learning.
Exactly.
But a lot of the scholars in the Islamic world found it very obscure until they really understood the relevance of it. There are lots of stories about why they found it obscure. I think there's a story that's someone who tried to explain it to the caliph in Baghdad, didn't speak Arabic, didn't speak Persian, so you had to have someone translating into Persian and someone translating Persian to Arabic. So it's not surprising they found it obscure. But it became one of the texts that if you wanted to understand mathematics, you had to read what they called the Sindh-Hind and the number system.
And obviously, in the ancient world, there are many traditions of astronomy. There's Greece, there's Babylon, there's ancient Persia. What are the things that are specific to India? What are the Indian contributions that that the Greeks didn't have, that the Babylonians didn't have, and the Persians?
Well, I think there are lots of examples of early development of mathematical techniques in astronomy, for example. The birth of what we call trigonometry today, so sines and cosines and tans, is absolutely crucial in astronomy. And so what Indian scholars, people like Brahmagupta, who was as great an astronomer as he was a mathematician, were doing were mathematizing astronomy. So using mathematical techniques to help them understand and study the heavens. Of course, this is all before telescopes, and so there were various instruments that were developed in different parts of the world that got sort of copied elsewhere. Astrolabes, for example, were hugely influential in Indian astronomy. One of the concepts I find most fascinating is that, we think about Copernicus as the great astronomer who said the Earth goes round the sun, not the sun around the Earth. So, the ancient Greeks thought the Earth was the center of the universe. The Geocentric Model, this is as explained by Ptolemy, the great Alexandrian astronomer. And we say, well, obviously that's wrong. But Copernicus comes along in, many centuries later and says, no, it's the Earth that goes around the sun. Astronomers in India had already proposed and suggested that, in fact, the Earth goes round the sun. They even suggested the Earth spins on its axis. But for a number of reasons, that never really caught on. I have a feeling it's because the giants of Indian science, like Brahmagupta, weren't so keen on the idea that the Earth goes around the sun. So other lesser astronomers may have it right, but almost got slapped down by the bigger names. So Brahmagupta
was like the Greeks. He was geocentric, wasn't it? Aryabhata thought that the Earth was the center.
That's right. That's right. Yes. So Brahmagupta comes along because Brahmagupta was so influential. That idea of heliocentrism, the sun at the center, didn't really catch on in India, as happened in other parts of the world as well. Even in ancient Greece, there were Greek astronomers who proposed it, that the sun was at the center, and that idea just didn't propagate. Sometimes you have to wait when the time is right for the truth to come out.
Now, two more ideas that Brahmagupta is the first to write about, or certainly the oldest surviving text: zero and the idea of negative numbers.
Yes, yeah, I find these wonderful because we talk about what did Indian mathematics give the world? Well, it gave us the decimal system. Yeah, that's great, but what people don't quite appreciate is the idea of zero and negative numbers. The notion of negative numbers, I believe, goes back almost 2 millennia. Because in Indian mathematicians treated the idea of debt as being the mirror image of profit, of credit. And they associated negative numbers with debt quite naturally. And today we think, well, that's quite normal. If you have an overdraft in your bank of, have made £200 or whatever, that's minus, that's negative. But the rest of the world didn't catch on to this. It seems that the mathematicians of the rest of the world just weren't clever enough to catch on to negative numbers as quickly as Indian mathematicians did. The story of zero I think, is even more fascinating because when we talk about zero, we have to be sure we're talking about the right thing, because there's zero as a symbol that's, as a placeholder to distinguish between 11 and 101. Zero as a symbol goes all the way back to the ancient Babylonians, 300 BCE. So that's a very old concept. But just because you can draw a picture of what zero means doesn't mean you understand it as a concept. The notion of zero as indicating nothingness, the void, I think goes as exactly. But I think that the idea actually, as far as I'm aware, starts with Aristotle in ancient Greece. So although sunya, yes, means the void or nothingness, the notion of the vacuum, the lack of anything, the void, goes all the way back to the ancient Greeks. But again, that's not a mathematical definition of zero. The idea that zero is a number between negative and positive, between +1 and -1, that we can trace back to people like Brahmagupta.
Oh, interesting. So Aristotle has the idea of nothingness, but he doesn't see it as a number.
Yeah, but not a number. But the idea that you can multiply a number by zero and that gives you zero. We learn that at school now, and it's obvious.
But it's not an obvious concept.
Yeah, divide a number by zero and you get infinity. Again, that's quite an abstract concept. Again, developed and really well understood by Indian mathematicians like Brahmagupta.
I've been reading a very interesting new book out a couple of years ago by a guy called Michael Willis at the British Museum. And he's been working on the Gupta sacred site at the heart of the Gupta dominions, where there were apparently a great number of astronomical sundials and things which you can still see in the rocks in Udaygiri. And his idea is that in Udaygiri it's arranged so you can measure the solstices, that you have the sun coming and going. and that this was a Gupta royal sacred site where astronomy was being used in a sense to enhance and legitimize kingship. This was, in other words, not only have you got the scientists working in abstractions, this is very practically put to use by kings to cement their rule.
Yeah, I think it's interesting because when astronomy developed in the Islamic world, it was in the service of religion. It would, and again, you can see a practical reason for that. You know, they want to know the phases of the moon. They want to know the time for prayer, the month of Ramadan for fasting, and so on. So it's very much is in the service of religion. The astronomers would live in mosques and they'd have their sundials there. It's interesting in India that it was seen as a sign of prestige. To have astronomers working for the king to give him advice was it's a different concept that we don't really see elsewhere.
And one concept that does go into this world is the whole idea of astrology, which today, in a sense, we dismiss scientifically, but at the time is very closely linked to astronomy. Yes. The idea that you can predict the future by studying the heavens is very, very strong.
Yeah, as you say, today we know astronomy is a science. It helps us understand the nature of the cosmos, and we know so much now. But astrology now is a bit of fun. It's not, don't take it seriously. We know now the forces that govern the universe, and we know that distant stars and planets can't control what happens for us here on Earth. But
there will be people who would dispute that here, but
which is why I'm saying it. I just want to start an argument. Yeah, come on then, astrology nonsense. But yeah, I mean, but back in the early period of the Indian scholarship, and indeed in the rest of the world, there wasn't a distinction between astronomy and astrology. There were a few scholars around the world who tried to make a divide in the same way that they tried to divide between chemistry and alchemy. Right. One's a science and the other is based on is more sort of spiritual or based on other belief systems. But you can see the reason why astronomers were also keen on coming up with astrological charts and predictions for their leaders, for their kings. Because the king wants to know when is the best time to go to war, or what are the star signs that needed for when to plant your crop, and so astrology is so embedded as a part of the culture that you can see it has a use culturally, if not scientifically.
So you mentioned the Islamic world, and so let's take the story on the next leg of the journey westwards. So in 711, you have Muhammad al-Qasim conquering Sindh and Islam reaching what's now, I suppose, Karachi, as far as modern Pakistan. And very soon after that, you get Indian sadhus making their way into the heart of the Arab world. You have Indian embassies bringing the books of Brahmagupta and the learning of Indian astronomy and mathematics to Baghdad. Talk a little about that. So Baghdad has just been founded. Caliph al-Mansur is on the throne. What's the intellectual world there which the Indians are coming into?
Baghdad, once it was very quickly, once it was built and designated as the capital of this new, as you say, rapidly expanding, vast Islamic empire. They got as far as Karachi in the east. They got as far as Spain in the west. But Baghdad really was the center. It was the place to be. Part of the ruling family, the caliphs or the Abbasids, were very keen on scholarship. For them, the idea of getting books and translating them from Greek, from Persian, from Pahlavi, from Sanskrit, all into Arabic, became an obsession. So scholarship and learning was the thing to do. It was fashionable. And that meant that Baghdad became the place, if you wanted to go and work, whether you're a musician, a theologian, an astronomer, a mathematician, a medic. Baghdad was the place you could go where you could receive funding. you could earn a living being a scholar.
And
so
the caliphs
all around the world.
In a sense, collating all the different learning bodies of learning from all the different cultures of the ancient world: Roman, Hellenic, Babylonian, Persian, and particularly in terms of astronomy and mathematics, the learning of India.
Yeah, it was the first time in history that you had a bringing together, a synthesis of all these different cultures and ideas. You would have had, when Alexander the Great traveled, would have been some exchange between Indian and Greek scholarship. India and Persia, would have overlapped and exchanged and translated from Pahlavi to Sanskrit and back and forth. But in the Islamic world, and in Baghdad in particular, and the famous House of Wisdom, this is the first time, as you say, we see all these different ideas coming from all around the world and all being synthesized and translated into one language, into Arabic, because of course that was the language of the Quran, and so the language of the official language of the empire. So anyone who wanted to make a name for themselves in their field, whatever it was, really had to travel to places like Baghdad and write their text in Arabic, which is the reason why very often we talk about that as the golden age of Arabic science, even though they weren't all Arabs, of course.
And one of the people who weren't Arabs were the Barmakids, the vizier's family, who I think were from Balkh, which is in modern Afghanistan. And these guys were the hereditary Buddhist abbots of the big Buddhist monastery in Balkh. So again, of Indic culture. They came from a world Buddhist.
Absolutely, yeah, and hugely influential in the Abbasid, higher echelons of power. Many of these Barmakis became the viziers, the advisors to the caliph himself, including
Jafar, who's in the Disney version is the villain of the 101 Nights.
He's the villain. In reality, he wasn't actually the character himself. The caliph's advisor wasn't a villain. He was a very learned and scholar person who really sort of supported a lot of scholarship and a lot of translations.
Disney has libeled this guy, as well as mispronouncing him as Jafar.
Jafar, yes, Jafar as opposed to Jafar. Yeah.
At this point, you've got now Indian star tables, astronomy, trigonometry, prediction of eclipses, and algebra, all making their way into this great stew of learning in Baghdad.
Yes,
who are the characters who are overseeing this? I'm thinking, Al-Khwarizmi.
Al-Khwarizmi and Al-Kindi. Yes, yeah. So yeah, I think that there are a number of names. There are people who are sort of rather more obscure. For example, it's argued the first person to translate Brahmagupta's Siddhanta into Arabic was an astrologer by the name of Al-Fazari. In Mansour's
one of the inventors of the astrolabe, isn't he?
Fazari? Absolutely, yes. I think sometimes in history there are a number of Al-Fazaris, but I think this one very early on in the 8th century, an advisor to Al-Mansur, the first caliph of the Abbasid period, he translated the Brahmagupta's work into Arabic, but he wasn't as influential as some of the scholars that came a little bit later in the early 9th century, and the two in particular who are household names probably in most cultures around the world. There's Al-Kindi, the great philosopher of the Arabs. He's an Arab working in Baghdad, and probably even an even better known name, Khwarizmi, the Persian mathematician. So they were both...
After whom we get the word algorithm.
Algorithm, which is the Latinized version, after the Latinized version of his name, Algorithmus. And also he wrote the very first book on what we would today call algebra, because of the title of his book, Al-Jabr, Kitab al-Jabr, the Book of Completion, was regarded as the very first text on just doing algebra correctly. But for our story, I think what that was of most relevance when it comes to Al-Kindi and Khwarizmi is that they introduced the Indian decimal system to the Arab world. They wrote books about it. They talked about how convenient it was and how useful it was. What's interesting is that it took a long time for the rest of the West to cotton on to this idea, just how useful these numbers are.
One point I think that's probably important to make here is that one sees a lot in the kind of right-wing internet that the Arabs appropriate Indian learning, that they steal Indian learning. One thing I was very struck with reading about this recently is how much they acknowledge the Indian origin of their studies. They very much, I mean, Al-Khalili's title is the Book of Hindu Calculation. He actually, in the title,
absolutely. Yeah, and even today, yes. So I think Al-Kindi also wrote a book on Indian numerals, Kitab fi Isti'mal al-A'dad al-Hindi, the book for the use of Indian numbers. Yeah. So certainly then, and even today, when in the Arab world, when you talk about what in the West, in English, many will say Arabic numerals. In Arabic, they're called Indian numerals. So it's very much an acknowledgement that they are not pretending that they invented them, or if they do, they're ignorant of the true origins of these numbers.
So we've got about 5 minutes to questions, and so let's fast forward. How does this system? So it's invented, decimal system, and these numbers invented in India. The symbols of these numbers are there from the time of Ashoka. They make it to Baghdad by the 8th, 9th century. How do they end up in Europe? Maybe we could talk about Fibonacci.
Yes. So Fibonacci is one of a number of Europeans in the 11th, 12th, 13th century who realized that if they wanted to find out all the clever stuff, or the scholarship in mathematics and astronomy and so many other areas, they weren't going to find it in Europe. Europe was still in the Dark Ages. There were pockets of scholarship here and there of people trying to sort of hold out against the ignorance and the superstition in Europe. And many of those scholars knew they had to travel to the Islamic world to retrieve the great Greek texts. So they were aware of the work of the ancient Greeks, Aristotle and Euclid and Ptolemy and Galen and so on. What they did when they got to places like Baghdad and in Spain, Cordoba and Granada, exactly. So there were these centers which became a focus of translation, a translation movement from Arabic into Latin. And amongst these Arabic texts were original books written in Arabic, but also Sanskrit texts from India that had been translated into Arabic. So you see these texts, they sort of hop from one language to another. And people like Fibonacci, the great Italian mathematician, discovered the work of Khwarizmi. So he discovered algebra and at the same time discovered this wonderful numbering system, the decimal system. So he takes it and tries to disseminate it throughout Europe.
And Fibonacci's father is running a Pisan trading outpost in what's now Algeria, and he grows up learning Arabic.
So he learns to speak Arabic. So that's the crucial thing. He's able to read the texts of people like Khwarizmi in the original Arabic, and I think he refers to Khwarizmi as Mehmet, based after Khwarizmi's first name, Muhammad. And so he can translate quite, skillfully these Arabic texts into Latin. But
as a patriotic Scot, I should mention here the role of Michael Scott, I was brought up with tales of him being a wizard in the borders. But in reality, he was the head of the court of Frederick II, who's the king of Sicily and much of Italy and the Holy Roman Empire. And he brings Fibonacci from into the center of his court and disseminates all this stuff out. So we have a Scot, and then Adelard of Bath, an English. Adelard
of Bath, yes.
Tell us about him. What's Adelard of Bath up to?
Oh, do you know? I'm trying. There are a number of these characters: Adelard of Bath, Gerard of Cremona, Robert of Chester, and these are also medieval scholars who essentially worked almost in isolation. So, unlike the scholars of Baghdad, in the 9th century in the House of Wisdom, where you're surrounded by other thinkers, or you go to Alexandria and the Library of Alexandria and some of the wonderful work of the Greeks. A lot of these scholars in Western Europe were working very much in isolation, and so in a sense, I feel we need to give them even more credit, that they're able to find out where in the world these wonderful texts are, and to try and disseminate them, within their own culture. It must have been incredibly difficult. William of Ockham is another,
Right.
another one.
So just to, in a sense, bring this to its final resting place. So we started in India, we've moved to Baghdad. Fibonacci sitting in Algeria, and Gerard of Cremona sitting in Toledo are bringing these ideas now into Europe. The first universities are opening on the edge of the Islamic world in Paris and Bologna, Salerno, picking up this idea of a university from the Islamic world. And how far can you say that the decimal system and the advances in mathematics that take place in Italy, having got this new technology in a sense, then in a sense powers the Renaissance, because it's Italian banking and Italian money lending and calculation, which then moves the whole Western Europe into the Renaissance. Can India take distant credit for some of this?
Absolutely. I mean, the science and learning and scholarship, and a lot of, particularly in areas like mathematics, you cannot start from scratch. Everything is built on foundations that came before. The Renaissance in Europe and the scientific revolution wouldn't have happened without the work of the Greeks, or the work of in the Islamic Empire, and the mathematicians of India, the mathematicians and astronomers of India, when they're developing the decimal system, the placeholding system, zero, negative numbers, how to work out square roots. The mathematics that we just use today and take for granted wouldn't have happened without these great thinkers. Just a few hundred years, it's about 1,500 years ago. So it's absolutely vital. We owe a huge debt of gratitude to some of these mathematicians, without whom, well, I don't know. Maybe we'd have found it from somewhere else, but it certainly helped kickstart the Renaissance.
Absolutely wonderful. Fantastic. So we've got about 10 minutes left, I think, for questions, and they're pouring in the great streams of them coming on this feed I've got in front of me. So Subhadeep Majumdar asks, how do you think the invention of numbers and digits influenced literature in ancient history? Has Aryabhata mentioned about relativity of motion?
It's difficult to tie the influence of numbers to other ideas outside of mathematics.
Somebody else was asking about the link between numbers and music, another interesting field.
That's certainly very clear. In fact, back at the time of people like Aryabhata and Brahmagupta, music was a branch of mathematics. It was, you had arithmetic, you had geometry, and you had music, and so much of music is mathematical. We understand that. We listen to work.
Fiendishly complicated Indian tals.
Right, absolutely, and I think again, Al-Kindi, the Arabic philosopher, wrote a lot about music, and he understood some of the differences culturally in music coming from different parts of the world.
Many other questions. Pinak asks, engineering in Arabic is called Hindisa. Presumably Hind refers to India?
I was talking to a friend some years ago, and he says it's obscure where the Handasa, engineering actually comes from. I'm not sure. it may be one of those occasions where we try it, where one can try and lay claim and say, well, that originates from India. The etymology of that word, Hendasa, isn't clear to me. I'm sure it may be well known to others, but I'm afraid I can't say for sure.
Interesting question from Sudhir Tandon. He says, did Indian architecture and spatial design influence the Arab world?
It did via Persia. A lot of in the early Islamic period, in the Abbasid period, the Abbasids were in love with Persian culture. For them, anything Persian was good, was great, and so they were very influenced by Persian literature, Persian architecture, and Persia and India. Before the Islamic world, there was a lot of overlap between them. So in terms of designing temples and palaces and so on, I would imagine a lot of that influence would have just sort of passed from east to west over the course of a number of centuries.
I believe there are some references at the time of Alexander the Great to the libraries of the ancient Persians containing Indian works.
So that goes back a very long time. Absolutely, yes.
You have the idea of diffusion of Indian ideas already by the time of Alexander the Great in 300 BC.
Yes, yeah. I mean, that's the thing. It's really difficult to draw lines and separate, what is Indian influence, what is Persian influence, what is European influence. These ideas cross-fertilize and disseminate across. Alexander the Great is a very good example of how cultural ideas can transfer from very different, distant parts of the world. You can't just say this came from this part of the world or that came from that part of the world. Ideas and ideologies are always being exchanged. You would know far better than me as a historian. What do I know? I'm a physicist.
Interesting question from Renita. She said, how did the certainty of maths and science evolve as it went from east to west in regard to religion? In other words, in the sense that the battle between science and religious ideas.
I can really only say what I know about what happened in the Islamic world, and there was certainly an acknowledgement that a rational picture of the world, whether mathematically or whether just by observation, carrying out experiments, what we would call science today, went hand in hand very comfortably with ideas from religion, in a way that sometimes one feels quite frustrated these days when somehow science and religion are put up in conflict with each other, that somehow there's a battle between them or a friction. But certainly in the early Abbasid period, for example, even though everything is driven by this new religion, there was an understanding among the scholars that God's given me a brain, I better go and use it and find out about the world rationally instead of making stuff up. And I think that would have been the same among any of the great cultures in history, including certainly the golden age during the time of Aryabhata and Brahmagupta.
Interesting question here from Sachdev Ramakrishna, who asks, could you comment on the work of Fazari and his use of Indian mathematical texts?
If it's the Fazari who is credited with the first astrolabe in this,
that Fazari, yeah.
Not so much is known about him, and I think part of the problem is that, as I mentioned earlier, there are a number of scholars in the Islamic world, and Arabs and Persians, by the name of Al-Fazari. He certainly was an astrologer at the time. Mansour surrounded himself with a number of very influential astrologers. Al-Fazari was one of them, but he was also well versed in mathematics, well versed in many languages, and so certainly credited with the first translation. A lot of these texts from Sanskrit translated into Arabic underwent a number of cycles, a number of editions, the same as the works of the Greeks translated into Arabic. And so there may have been other more accurate, more careful translations, but certainly Al-Fazari had studied the work of Brahmagupta and is regarded as the first person to translate Brahmagupta. That's what he's known for best of all, I think, in history, to have brought Brahmagupta's work to the Islamic world.
Well, one question I'd like to ask is, how far are Fazari and Al-Khwarizmi inventing new mathematical ideas, and how far are they merely transmitting Indian ones?
It's certainly true. Al-Fazari, I would say, isn't the original mathematician that Al-Khwarizmi was. Khwarizmi, I think there is no doubt that on the one hand, yes, he's transmitting the Indian decimal system. Yes, so he sees it. He sees the usefulness of the decimal system that's coming from India, and says, why aren't we all using this? And he translates the work into Arabic and writes about it and tells the world how useful it is. But in terms of his textbook on algebra, Khwarizmi really is an original thinker. Although people are trying to do some basic algebra before that, going all the way back to the ancient Greeks, even the Babylonians were doing a bit of what we call solving quadratic equations. Khwarizmi is the first person to really develop algebra as an independent field of mathematics. It's not number theory. It's using symbols, manipulating symbols according to certain rules that he generalizes, that, x equals, y plus x equals 3, the stuff that we learn at school now goes back as far as Khwarizmi, and really before him, it wasn't really algebra. So he is a great mathematician.
Correctly, I read somewhere that sine, the sine function was invented in India, but the cos and tan were Arabic additions.
Yes, the sine, I wish I could remember the details of the story of the etymology of the word sine, but it comes from the arc of a circle, and the chord, right, lines, or the bow of an arrow, the bow of the chord of a bow of an arrow. And there's a number of steps of translations from the Sanskrit until you get to sine. The word we use now, sine, it comes from the Latin sinus, which means pocket, I think. A translator from Arabic into Latin mistranslated the Arabic because the Arabic was using the Sanskrit original. So there's all this, you see this again and again, confusion of translations from one language to another. But yes, sign comes from India.
Zero. Sunya in Sanskrit becomes, what's the Arabic?
Sunya becomes Sifr.
And then that becomes the English cipher.
It becomes English cipher, yes, and it then the Latinized version of Sifr becomes Zephyrum, and from Zephyrum you get 0, and so yes, again, all these multiple steps, but the 0 that we use today can be traced back to Sunya in Sanskrit.
I think, Jim, we are very close to the end. So, do you want to make one last sort of summing up statement? What if you had to put in a short sentence? What do we owe? What is the gift of Indian mathematics to the world?
Without Indian mathematics, I think, well, we may have developed the modern world, but I think the modern world that we have today, with the decimal system that we take so for granted, and the technologies that have changed our world, can essentially be traced back to this technique that the rest of the world took hundreds of years to realize how useful it was. Because in the West, they were just using letters instead of numbers. And they didn't realize how useful and how brilliant the Indian numbering system was. Eventually, they picked it up. But I think a huge debt of gratitude and thanks to some of these wonderful characters from history that certainly outside of India deserve to be far, far better known.
Jim Al-Khalili, thank you so very, very much. That's very kind.
My pleasure.
Thank you, Jim. Thank you, William. That was just fascinating. And we still have questions streaming in. So if you don't mind, we'll send some of them to you. And if you can answer some of them, we'll then post them back onto
Absolutely.
Facebook. Thank you all for watching and being such a great audience. And like I said, I'm really sorry. It was such a fascinating conversation, but we couldn't take all your questions. We thank our official radio partners, Red FM, Bajate Raho. Please do remember to log in at 9 p.m. for our next session. The Age of Anxiety. Casey Schwartz and Amrita Tripathi in conversation. A crucial conversation about uncertainty and anxiety, collaterals of our times, and the power of focus and attention to shape our lives as we sit with our thoughts and our screens in isolation, trying to stay sane. Now, for all of you who like to stay logged on, we have a special sequence from the Jaipur Music Stage archives. Harpreet is a versatile artist who sings original music compositions in Hindi and Punjabi, as well as in a range of Indian languages and dialects. With a powerful stage presence, he's best known for creating musical scores for epic works by poets like Kabir and Bulle Shah. His blend of soulful poetry, sung to the pulsating sounds of the guitar and percussion, are at once unique and innovative, familiar and foreign. Enjoy, and remember, log back on at 9 p.m.
Okay, the last song. Everyone. झूम झूम मृदु गरज गरज घनघो, राग अमर अंबर में भर निजरो। झूम झूम मृदु गरज गरज घनघो, राग अमर अंबर में भर निजरो। झर 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 निर्झर गिरि सर में, झर झर निर्झर गिरि सर में, घर मरु तरु मर मर सागर में। हरित तड़ित गति चकित पवन में, हरित तड़ित गति चकित पवन में, मन में विजन गहन कानन में। आनन आनन में रव घोर कठोर, राग अमर अंबर में भर निजरो। आनन आनन में रव घोर कठोर, राग अमर अंबर में भर निजरो। अरे वर्ष के हर्ष बरस तू बरस बरस रस धार, और ले चल तू मुझको बहा दिखा, मुझको भी निज गर्जन भैरव संसार। अरे वर्ष के हर्ष बरस तू बरस बरस रस धार, और ले चल तू मुझको बहा दिखा, मुझको भी निज गर्जन भैरव संसार। पुथल पुथल कर हृदय मचा हलचल, चल रे चल मेरे पागल बादल चल। पुथल पुथल कर हृदय मचा हलचल, चल रे चल मेरे पागल बादल चल। झूम झूम मृदु गरज गरज घनघो, राग अमर अंबर में भर निजरो। झूम झूम मृदु गरज गरज घनघोर, राग अमर अंबर में भर निजरो। Thank you so much everyone. Thank you team.